Hey everyone, it's Shakya and welcome back to my YouTube channel. So this is my first video in my data structures and algorithms series, and today we're going to talk about ListStacks. So let's get started. Alright, so a list stack. What is a list stack? So list stack is a stack that is implemented using a list. So then what is a stack? So a stack is a linear data structure that follows the LIFO principle, that is last in and first out. So what this means is that the last element that is added to the stack is the first element to be removed from the stack. So here we have a stack which has 1, 2, 3 and 4. So in this stack, the last added element is 4. So imagine if we add another element, that is 5. So this is the last added element now. So if we want to remove an element, we have to remove 5. So the last added element is the first element to be removed. So if you talk about the characteristics of a stack, as I said, it has the last in first out principle, and also it has single-ended operations. So both the insertion and the deletion of elements occur at one end, so that end is referred to as the top of the stack. So when you want to add an element, we add to the top of the stack, and if you want to remove an element, the element at the top of the stack is what gets removed. So then let's talk about some of the primary operations performed on a stack. So we have the push function. So this is the operation that is used to add an element to the stack, and then we have pop. So this removes and returns the element that at the top of the stack. And then we have peek. So this operation returns the element at the top of the stack without removing it. So in the pop operation, you remove the element and returns the value of that element. But in the peek, it doesn't remove the element, it just returns the element at the top of the stack. So and then you have the isEmpty operation. So this operation checks if the stack is empty or not, and then returns a Boolean value. So it returns true if it's empty, false if it's not empty. So a list stack. So a list stack is a stack that is implemented using a list. So a stack can be implemented using a linked list. So let's take a look at the linked list structure as well. So a linked list has a node structure. So each element in the stack would be a node in the linked list. So a linked list has two parts in the node structure. So one is data and the other is the pointer. So the data is the actual value that is stored in the stack, and the pointer is a pointer to the next node in the list. Or if it's like the last node in the list, it would point to null. So let's imagine we have a stack and it has the values 1, 2 and 3. So in a linked list, so there would be a node with 1 and then another node with 2 and another node with 3. So each of this would point to the next node. So here the memory address of the next node is stored. So let's just say that the memory address here is 12 and this is 11. So here the memory address would be stored. So this would know where the next element, next node is at. So this would store 11. And since this is the last node, it would have null. So it would store null. So this is the structure of a linked list. So let's look at the operations of a stack using a linked list. So as we said, one of the main operations in a stack is the push. Let's take a stack and it has 1, 2 and 3. So 3 is the element at the top of the stack. So if you take a linked list, so we have 1 and this would have null, null, and then we have 2 and this would point to 1, and then we have 3 and this would point 2. So 3 is our top of the stack value. The top value is 3. So if we want to add 4, so we want to push 4 onto the stack. Okay, so in the stack it would add 4 onto the top, and then 3 would no longer be the top of the stack. The top of the stack would be, the pointer would point to 4. So the point at 3, the top of the stack point at 3 would point to 4. So in the linked list, first if we push 4, the first thing that would happen is it will create a node and then the data would be added. So the data is 4. So we have a node with the data 4, and then it would set the next pointer of the new node to point to the current top of the stack. So our current top of the stack is 3. So it would set the next pointer of the new node to point to 3. And then it would update the top of the stack to point to the new node. So this would no longer be the top of the stack. This would be our top of the stack. So this is how the push operation happens in the linked list. So the next operation is pop, that is removing an element. So let's take the same stack. We have the stack and we have 1, 2, 3 and 4. So this is our top of the stack. So in the linked list, so let's draw the linked list as well. So we want to perform the pop operation. So the first thing that we do is check if the stack is empty. That is, if the top is null. So, and in this case, the stack is not empty. So it would store the data of the current top node, that is 4, and then it would move the top pointer to the next node in the list. So this would no longer be our top, this would be the top, so this. And then it would return the stored data, and then it would return the value of 4, and this would be our top of the list, top of the stack. Okay, so then we're going to talk about the peak operation. So let's take the same stack. We have, so let's take the stack 1, 2, so we have the stack 1, 2, and 3, and 3 is the top of the stack. So in the peak operation, first it would check if the stack is empty, and in this case the stack is not empty, and then it would return the data of the node pointed by top. So this is the node that is pointed by top, so it would return the value 3. And then the isEmpty operation is used to return true if the top is null. So that means like it checks if the stack is empty. So if the stack is empty, it will return true. That means there is no values in the stack. Like if there are values in the stack, if it's not empty, then it would return false. So those are the main operations on the stack. So now let's talk about a few advantages of a stack implemented using a linked list. So the stack can grow or shrink as needed because in the linked list, it does not have a predefined size limit. So as long as there's memory available, it can grow or shrink as needed. So it also has efficient operations. So the push, pop, peak and isEmpty operations have a time complexity of O1 because no matter what the size of the stack is, all these operations can be done in constant time because all of them include manipulating the pointers of the head of the list. So it has efficient operations. So now let's take a look at the code in Java of implementing a stack using a linked list. Okay, so let's take a look at how we can actually implement this. So I'll be using Java, but you can use any type of language like Python or C++. So first here I have created the public class ListStack. So this is a generic class, that means that it can store any type of data like integer or string. And then I have the node class. So a node has two parts, the data and the next. So here we have the data which would store the actual value, and the next which would point to the next node in the list. So each time you push a new element, you would create a new node. So here the top would point to the top element of the stack, that is the most recently added node, and the count would keep track of how many elements are currently in the stack. So when you first create the stack, the top would be null and the count would be 0 because the stack is empty initially. And then we have the constructor ListStack. So this would initialize an empty stack when you create a new one. So then we have the push function. So T is the data type and data is the value that is going to be added. And then this line would create a new node, and then with the .next it would link the newly created node to the current top node, and then next the new node would become the top node. So the new node would equal to top, and then the count would be increased by 1. So that is how the push operation would work. And then we have the pop. So first it is going to check if the top equals to null, so that means that the stack is empty. So if the top equals to null, it would print that the stack is empty and it will return null. So if the top is not null, then the first thing is it would store the top element. So T is the data type, and then we have value. So the top dot data would be stored in this value variable. So the top data is going to be stored in the value variable. So next, the top dot next element will be the top element. So the top pointer would move down, and then the count would decrease by 1. And then we have the peek operation. So it would check if the top is null, and if it is, it would print the stack is empty and return null. And if not, it would return the top dot data, that is the data of the top node. So it would simply look at the top element, and without removing it, it would just return it. And then we have isEmpty function. So it will return if the top is equal to null. It will just simply check if the stack is empty. So we have the size function. So it will just return the count, that is the number of elements in the stack. And then we have the main method. So let's check this code. So first we have created a new stack named newStack. So then we have 3 push operations, 10, 20 and 30. So if we draw the linked list and the stack, it would look like this. So first we're going to pop an element in the stack and we're going to print it. So in the stack, if we pop 30 is what is going to be popped, and so it should print 30. And then we're going to see the top element, so we're going to use the peek function. So if we peek, it's going to be 20 because it's the next. Since we popped 30, 20 is the top of the stack. And then we're going to check if the stack is empty, and then the size of the stack. So the size of the stack is going to be 2, and the stack is not empty, so that would return false. So let's run that part and see. So as you can see, we have popped 30 and the top element is 20 and is the stack empty is false and the current size is 2. So that was an integer list stack. So let's try with a string one. So again, I have created a new list stack named string stack. So I have pushed A, B and C, and then we pop the elements. So let's draw the stack and the linked list again. So if we pop, what is going to be popped is C, and then the top element is going to be B. So if we peek, it's going to be B, because since we popped C, B is the top of the stack. And then is empty, so it will return false because the stack is not empty. And then the size again would be 2. So let's run that part and see. So as you can see, we have popped C, then top element is B, is stack empty is false, and the current size is 2. So that's it about ListStacks. I hope you guys understood, and if you have any questions, feel free to drop them down in the comments below. If you found this helpful, don't forget to like and subscribe and hit that notification bell so you will be notified for any future videos. Thanks for watching, and I'll see you in my next video.